Okay, good morning. So if you remember last time we wrote these examples but didn't solve them, I just want to solve these 4 problems for you and then leave you to practice on your own if you have more time. I don't know if you have seen Google Classroom, there's a long list of pages that you can do in the book. And then I will start mathematical induction on Thursday, and I think it needs at least 2 sessions. So we have to arrange, let me pause the video, I think. You don't need to record this. Okay, so let me start solving them so that if you need time to practice on your own, you can have time to do that as well. So in a geometric progression, we have these conditions. We are supposed to find the common ratio, yes? So there are 2 formulas important. Let me write them in front of your eyes. So what was that? Tn, the nth term is the first term multiplied by the common ratio to power n minus 1. And then we have another formula Sn, which is T1. We can write it in 2 different ways. Let me choose this alternative here. R to the power of n minus 1 divided by r minus 1, or the other way around for both of them. Okay, so if you want to solve that problem, we can start from this. Let me write here. Instead of T1, instead of T5, I can write T1. R to the power of 1 less, which is 4, minus, instead of T1, I just write T1, is equal to 20. So that is one equation. Of course, you see that in this equation, I have 2 unknowns. One of them is T1, the other one is R4. So I need one more piece of information, and it is provided for me in the problem, yes? And that is S10. S4 is equal to 10. So S4 means that go to this formula, replace n with 4 everywhere, and the answer is supposed to be 10, yes? So it becomes T1, r to the power of 4 minus 1, divided by r minus 1 is given to be 4.
No, 10.
Yes, thank you. Usually the equations that you get in geometric progression are still a little bit harder than the equations that you get for arithmetic progression. And because of this power nature of that, yes. In arithmetic progression, we do not have powers, we have coefficients, yes. These n's will appear as coefficients, so that problem is easier to solve usually. So then it becomes 10. So then this is in principle nothing new. You have 2 equations and 2 unknowns. You should be able to solve it, but as I told you that the systems are usually non-standard systems. You need to find a way to be able to solve it easily. Do you have any ideas what to do here? But of course, in that case, it is really, really simple. Yes? What should I do for solving this system? So what you have to have in the back of your mind when you want to solve a system, you should do some algebra to make one single equation in one unknown. And of course, if the system is not standard, the method is not standard either. So you need to find a way, yes? You need to do some trial and error to see which one will work. But of course, in this case, I think it's really, really simple. Yes?
Why is it one out from the first equation and then put it in the second?
Yeah, and exactly, it becomes the numerator of the first equation. So it was very simple, this problem, yes? So if you realize that T1, I can factor it out, then it becomes R4 minus 1 equals to 20. And the good point is that exactly what in the numerator is this expression. So if I put it here, then this would imply that 20 divided by R minus 1 is equal to 10. So R minus 1 should be 2, because 20 divided by 2 is 10. So this means that R minus 1 is 2. So it's very, very simple. You see, R is equal to 3. And that is exactly what is demanded in the problem. For the second problem, we have only one piece of information. And then, of course, only R is wanted. And then we can write it in that way. So S8 is equal to 17 S4. So what can I write for S8? I write a formula, but if I replace n with 8, so it becomes T1 r to the power of 8 minus 1 divided by r minus 1. It is equal to 17 times larger than S4. But S4 is the same formula. The only thing that I have to is to write 4 instead of. Okay. So in principle, you should move it to the left-hand side and factorize it, but there are something that you can do easier. So first of all, I can multiply everything by r minus 1. If I multiply by r minus 1, the left-hand side and the right-hand side, this r minus 1 will be cancelled. And then I can divide everything by T1. Why should I divide? Why should I be able to divide that? I can only divide if I'm sure that T1 is not equal to 0. But of course T1 is not equal to 0, because if T1 in a geometric progression is 0, all other terms will also be 0. And this is not, of course in that case this will happen, by the way, because S8 is 0 and so this is a little bit ill-designed. So I should say that T1 is not equal to 0, because this might happen that T1 is equal to 0 and still this makes sense, yes? Because if T1 is equal to 0, it means all the terms will be 0. And then if I ask you what is S8 becomes 0, what is S4 is 0, so this is valid. So in principle, there is a space for having T1 equal to 0. So in principle, I should mention this in the problem. Of course, these special cases, we usually don't care. Okay, so in that case, I am safe if I divide by T1. So if I divide by T1, this T1 and that T1 will be cancelled. And then I will be left only with one equation. Unfortunately, that equation only involves r. And that is exactly what I want to calculate. Okay, what is your opinion here? So how should I solve this equation? In principle, this is an 8th degree equation. And I told you that polynomial equations are extremely hard to solve unless you can find a way to factorize it. In this case, you can, yes? So how can I factorize this or simplify that? Yes?
Can you use a conjugate rule?
On the left-hand side, thank you. So this becomes r to the power of 4 minus 1, r to the power of 4 plus 1, and then it becomes 17 r to the power of 4 minus 1. Yes? Okay, so let me move this one to the... By the way, if you want to divide by this, so you should make sure that r to the 4 minus 1 is not equal to 0. But still there is no guarantee that r4 is not equal to 1. So the safe way to solve that is to write it, to move it to the left-hand side. And then factor it out. Yes? And then when you factor this out, this becomes r to the 4 minus 1. From the first one, r to the 4 plus 1 is left. And from this one, minus 17 is left. Equals to 0. And if I simplify that, it becomes r to the 4 minus 1. And then I will have r to the 4 minus 16 equals to 0. But by the zero product rule, either the first one is equal to 0. So this implies that r to the 4 is equal to 1, or r to the 4 is 16. So this means that r is either plus or minus 1. This means that r is either plus or minus 2. So actually there are 4 alternatives for this problem if this is going to happen. So there is no unique answer for this problem. You can imagine 4 geometric progressions so that this can happen for it. And that value, that is independent of your T1. Let us check, for example, to understand it better. For example, let me start with 3, and let me choose r to be negative 1. The next one becomes negative 3, the next one becomes positive, negative, positive, yes? Negative 1, 2, 3, 4, 5, 6, 7, and 8, yes? this will generate this sequence for me if r is minus 1. Now, if I add them from the first term to the last term to the 8th term, what is the answer? It is 0, yes? And if I add from the first term to the 4th term, the answer is again 0. And you see that 0 is 17 times larger than 0. So that is working, yes? For 1 is also, but for 1, do you think it will work or not? Yes, let me check. Let me, for example, this time start from 5. And then what will happen? 5, 5, 5, if I choose 1. 1, 2, 3, 4, 5, 6, 7, 8. Do you think that this will work? So 8, it is 40. I don't think it will work, yes? So r equals to 1, it is not possible. But why we cannot see that? Do you understand what I mean? Apparently we got r plus 1 and minus 1 and r equals to plus or minus 2. But if we are careless, might be we say that all of them are acceptable. And then you see that there is a contradiction when I start for r equals to 1 and t1 equals to 5. I will get this one. If I add all of them, it becomes 40. If I add 4 of them, it becomes 20. And if I multiply 20 by 17, definitely it is not 40. So why the problem? Where is the problem here? Why do you think this discrepancy happens? There is a reason for that, and I have been careless when I was doing it. This formula, do you remember when I wanted to derive this formula, there was one assumption behind that. Because if you remember, I had to divide by r minus 1 to get this formula. And this cannot be done if r is equal to 1, because otherwise this doesn't make sense. Yes? So be careful. This formula is always valid, but the exception is that r equals to 1. And then it means that when I reach here to 1, I have take it out, because r shouldn't be equal to 1. It doesn't mean that you should immediately rule out r equals to 1. It tells you that you need to check it separately. If you want to use this formula for Sn, you are implicitly assuming that r is not equal to 1. So this is only capable of giving you the results if r is not equal to 1. But what happens for r equal to 1? Apparently you see that we have contradictions, so in this case r cannot be equal to 1. But I don't think we will face any problems with 2 and minus 2. Let us check. Minus 2, I don't know, let me just check, because I want to make the numbers small so that we can check it. So let me start with 1 this time. Every time I multiply it by 2, so it becomes 2, I don't know, 4. The next time is how much? It's 8, 16, 32, 64, 128, and finally 256. So then it would be a big problem if we want to add these numbers. If you add these numbers and add these numbers and you multiply the sum by 17, it should work. I think if you have calculator, you can convince yourself that this will work. So only minus 1, plus 2, and minus 2 are acceptable for this problem. So be careful. I should have mentioned that in this case. So if you remember, if you go back to the proof, at the very end, for finding Sn, I have to divide by r minus 1, but division by r minus 1 is allowed if r minus 1 is not equal to 0. So it means that that formula for Sn is valid if r is not equal to 1. Okay, so let me go to the next problem. Any questions, by the way? Okay, so the next question, S4 is given to be 240. So here, assuming that r is not equal to 1, I use the formula. So it gives me T1, and then I will have r, whatever it is, to the power of 4 minus 1 divided by r minus 1 is equal to 240. And then T2, we know what is the formula for T2, is T1 multiplied by 1R. T4 is T1 multiplied by R to the 3. On the right hand side I will have 3. T1 is just T1, and T3 is T1 T squared, T1 R squared. Okay, and then again you face a system of equations in two unknowns, T1 and R are unknown, and then you have two pieces of information. Okay, any ideas how to solve this one? Yeah, think a little bit about that. So, raise here. How should I solve this? So try to factorize as much as you can. So here T1R is in common. Here T1 is in common. So I can factor them out, yes? So here it becomes T1R. And then I will have 1 plus R to the power of 2 is equal to, here I can factor T1 out. It becomes 1R to the power of 2. So here, do you think T1 can be 0 or not? No, because if T1 is 0, the rest of the terms will be 0, and it is not possible for the sum of the fourth terms becomes 240. So it is clear that T1 is not 0, so I am on the safe side if I want to divide by T1. Am I safe to divide by 1 plus R2 as well? Yes, because 1 plus R2 cannot be equal to 0, yes? R squared is non-negative, and when I add 1 to it, it becomes at least 1. So it is not 0. So I can safely divide by this one as well. So be careful. Whenever you want to divide, you have to make sure that this is not equal to 0. Otherwise, instead of dividing, you have to move to the other side and factorize and use the zero product rule. But here, it is easier because we are on the safe side. We can just simplify. So what is left for me is just R is equal to 3. As simple as that. And then when I have R, I can put it in one of these equations, either this one or that one, to find T1. But I think it is easier to put it here. So a T1 is still not known. 3 to the power of 4 minus 1 divided by 3 minus 1 is equal to 240, yes? And then if you simplify that, this becomes 80. 80 T1 is divided by 2 is 240. And then 80 by this one is 3. So T1 is 6. So that was very, very simple actually. Okay, but I think the only good problem in this list is these two. So we want to find a formula for this sum. So this sum is neither a geometric progression nor an arithmetic progression, yes? So 9, the next term is 99. If you want to look at it from the arithmetic progression point of view, what is added is 90. But if I add 90 to it, it will not generate the third term. So it is not an arithmetic progression. And it is multiplied by 11. But if I multiply this by 11, it will not be this number. So this is not geometric progression either. So this is neither a geometric progression nor an arithmetic progression in the form that you see exactly here on the board. But still, I am asking you to find a closed formula for this. A closed formula means something which is equal to this sum but does not include these dots, yes? So you want to write a compact formula for this. Do you have any idea how to do that? Yes?
I think it's times 10 plus 9. Just between each.
Okay, but 10, so let me check your idea. You say that you multiply by 10 and add 9 to it, yes?
Yes.
So the first one will work, the second one will work, yes, every one will work. But the point is that we don't have any formula for that unless you can invent it yourself. So do you understand what I mean? So the pattern that you found is completely right, it works. But for that kind of pattern, so we don't know is what we can call this progress. This is not probably a progression. This is a sequence. But do we have any formula for the sum of the first n terms, even though you found the pattern? Because we only know how to. We have only two formulas, unless you invent it yourself for this particular case. I'm not saying it is not possible, but we don't have the formula. We only know how to add the terms of a geometric progression. We only know how to add the sum of the terms of an arithmetic progression. But as you said, exactly the pattern is right. Multiply by 10, add 9 to it. It is neither a geometric progression nor an arithmetic progression. Yes, the pattern you find is correct, but can you find a way to add them up? If I want to give you a guide, you can write each term in a way that when you see the whole picture, a geometric progression appears. But of course, some extra terms will also appear. It's not that hard. Okay, so let me pause the video and then you can think at least for 2 or 3 minutes for it. Because you just tell me the idea. The rest of the calculation I will do it for you. So, do you have any idea how to do it? Yes?
Now you're putting pressure on me.
No, precious. Yes.
But maybe if you have 10 multiplied by r, and
Yes.
then you take minus 1 for each.
Okay, but what that r is?
What, 10? Or
So you mean that, okay, tell me what to do. You mean,
so you take, your first r would be,
okay, so we have different r's. Then we will be in trouble.
No.
Yes?
No, the thing is, if you start with t1 as 10,
Yes?
that means that the formula for t1 would be, where's the...
The question is here, yeah? The formulas are also there.
Yeah. So that means that it would be 10 multiplied by r. Oh yeah, so that would work.
I don't know.
Okay.
You just convince yourself, just that.
So n is 1. R to the power of 1 minus 1 would be r to the power of 0.
Yes?
So t1 would work as, okay, so t1 is 10 and r is also 10.
No, it doesn't work, I told you. If T1 is 10 and R is also 10, you might generate one of them, but you are supposed to generate all of them. And I told you, no, don't make trouble
and
for
you
yourself.
minus 1
Don't.
for each one.
Okay, but the point is that even if that is the case, it is a slightly different from this. Then it is not a geometric progression. Yes, Martin?
Pattern is 10 to the power of n minus 1.
Exactly. So that's the nice pattern, yes? Thank you very much. So what we can write, instead of 9, we can write 10 minus 1, agree? Yes? Instead of 99, we can write 10 to the power of 2 minus 1. Because that's 99. And instead of the next one, we can write 10 to the power of 3 minus 1. And then 10 to the power of 4 minus 1. And if I continue, the last one is 10 to the power of n minus 1. Yes? Now if I ask you, is it a geometric progression? The answer is no. Is it an arithmetic progression? Still the answer is no. But the point is that you can start collecting the terms now, yes? You can write powers of 10 next to each other. So you can write 10 plus 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, up to 10 to the power of n. Yes? And then you can you have minus 1, minus 1, minus 1. So you can write minus 1 plus 1 plus 1 plus 1 plus 1. Yes? So now this one is a geometric progression. First term is 10 and the common ratio is 10. But we don't even, this is also an arithmetic progression, but this is simpler than that. You're adding 1 to it. How many times? N times. So this is, we don't have any problems with that. N summands. So what is the answer? It's simply n. Yes? And then this is a arithmetic geometric progression and the formula is in front of you, yes? The T1 is 10. R is also 10 in this case. How many terms I have from 1 to n terms? Minus 1 divided by 10 minus 1. And then I have minus n at the end. If you simplify it, it becomes 10 over 9. 10 to the power of n minus 1 minus n. Yes? So that is the closed formula for this sum. Now my question for you is that what is the closed formula for the second one?
Is it
Pardon?
Is it different?
Of course it should be different.
Yeah, I mean, yeah, of course.
Just
But
change.
is it the same? I mean, method or?
Now I want you to think about it. You shouldn't spoil the enjoyment of solving a problem, yes? Yes?
So it becomes, it's the same idea, but instead of minus 1, you do minus 3. So
No, it doesn't work, unfortunately.
It doesn't? Yeah.
You see, 10 minus 3 is 7, but 10 to the power of 2 minus what? Minus 3 is unfortunately 97, not 77. Yes?
I'm definitely careful with that. And the formula.
Huh?
10 y.
No, don't tell me the formula, just give me the idea. Because your idea is right.
7 out, you will have 1, 11,
Yes, yes?
111 and so on. And you can describe that as 10 to the power of n minus 1 divided by 10 minus 1.
No. Because unfortunately, 1, so you said that I factored this 7 out. Is that, yes, that's right. It becomes 1 plus 11 plus 773, 111, and it continues, you are right. Yes, that is right.
That formula is for each term.
No, but if you write, you are saying, what should I write instead of 1?
10 to the power of n minus 1 divided by 10.
So let me, 10 to the power of n minus 1,
Yeah, divided by 10 minus 1.
10 minus 1.
Yeah, that's the formula for each term. What the sum will be. So 11 is 10 to the power of 2
Yes?
minus 1 divided by 9. That will be 11.
Yes, you are right. This will work. And then we can add them. The denominator of each of them is 9. So I can factor it out, no problems. Then it becomes exactly the same thing. Yes, this method will work, but much simpler than that. So your idea was correct. I was thinking that you discovered what your answer is completely correct. So if you do this, it will work. But of course, do you agree that this sum is equal to 7 over 9? Oh, sorry, 7. So I make it 9. So I'm asking you, if I multiply this series, this sum, by some number, I will get this one. What that number is? It's very simple. I multiply this whole by one single number, then this will turn out into this
7
one.
over 9.
7 over 9. And then we already know about that, so you multiply that by 7 over 9. Yes? So that is exactly your idea, by the way. It's not different. But what I'm saying is that the second question mark here, this question mark, is equal to 7 over 9 times this. Yes? Because if I multiply 1 over 9 into this, it makes it 1, 11, etc. And then when I multiply it by 7, it becomes 7, 77, etc. Is that understandable? But we already calculated this one. It's on the board. So this becomes 7 over 9 multiplied by 10 over 9, 10 to the power of n minus 1 minus n. And then you multiply this inside. Yes? So then it becomes 70 over 81, 10 to the power of n minus 1, minus 7 over 9n. That is the formula for this one. Yes? Okay, so I will stop the lesson here. I have already written you a lot of recommendations. I hope that you can start working on them, and if you have questions, please let me know. So the next session and the next session I will start teaching you an induction, then I will give you time to practice again. Yes, thank you.